Quantum computing is one of the most revolutionary technologies on the horizon today. You've probably heard of it, but what is it really? And why is it such a big deal? In today's video, we're going to break down the complex world of quantum computing in a way that's easy to understand, from the basic concepts of how quantum computers work to how they differ from classical computers and the potential they hold for the future. We'll cover it all. So, whether you're a tech enthusiast, a student, or just curious about this fascinating technology, stick around as we explain quantum computing and how it's set to change the world. Let's start with the basics. What exactly is quantum computing? In simple terms, quantum computing is a new kind of computing that uses the principles of quantum mechanics, the science that explains how the smallest particles in the universe behave. While classical computers, like the one you're using right now, process information in bits, ones and zeros, quantum computers use qubits. A qubit can represent a 1, a 0, or both at the same time, thanks to a phenomenon called superposition. This allows quantum computers to handle and process massive amounts of data at once, solving problems that would take classical computers thousands or even millions of years. Alright, so how does quantum computing actually work? The magic behind quantum computing lies in two key principles: superposition and entanglement. Let's break these down. First, superposition allows qubits to exist in multiple states at the same time. In classical computing, a bit is either a 1 or a 0, but with superposition, a qubit can be both a 1 and a 0 simultaneously. This allows quantum computers to perform many calculations at once. Then we have entanglement. This is a unique quantum property where two qubits become interconnected, so the state of one directly affects the state of the other, no matter how far apart they are. This interconnectedness allows quantum computers to process information exponentially faster than classical computers by linking qubits together in complex ways. These principles enable quantum computers to solve certain problems in seconds that classical computers would struggle with for years. But it's important to note that quantum computers aren't just a faster version of classical computers, they're an entirely different way of computing. So how does quantum computing compare to classical computing? To understand this, let's use a simple analogy. Imagine you're in a library and you're looking for a specific book. A classical computer would check each book one by one until it finds the right one. This could take a lot of time, especially if the library is huge. But a quantum computer using superposition and entanglement could check all the books at the same time. It's like being able to search the entire library in a single instant. Classical computers are still incredibly powerful and efficient for most tasks, but they reach their limits with certain types of problems, especially those involving vast amounts of data and complex calculations such as cryptography, drug discovery, and simulating molecules for scientific research. This is where quantum computers come in. They can handle these problems much more efficiently, potentially transforming industries. Now let's dive into some of the real-world applications of quantum computing and why it has so much potential to change the world. One of the most exciting areas is cryptography. Classical computers use complex mathematical problems to secure data through encryption, but these systems can eventually be cracked with enough computing power. Quantum computers, on the other hand, can solve these complex problems much faster, which could be a threat to current encryption methods. However, quantum computing also holds the key to creating new forms of encryption that are virtually unbreakable, ensuring better data security in the future. Next is drug discovery. Quantum computers have the ability to simulate the behavior of molecules at the quantum level, something classical computers struggle with due to the sheer complexity. By simulating molecules, researchers could discover new medicines faster and more accurately, revolutionizing the pharmaceutical industry. Another application is in climate modeling. The climate is an incredibly complex system, and even the most advanced classical computers have difficulty modeling all the variables involved. Quantum computers could make it easier to simulate the climate, leading to more accurate predictions and better strategies to combat climate change. Finally, there's artificial intelligence. Quantum computing could significantly boost AI by allowing computers to process vast amounts of data faster, making machines smarter and more capable of learning in ways that classical computers simply can't match. While quantum computing is incredibly promising, it's still in its early stages and faces several challenges. One major hurdle is error correction. Qubits are extremely sensitive to their environment, and even the slightest interference from heat or electromagnetic waves can cause errors. Scientists are working on developing ways to stabilize qubits and correct errors, but we're still a long way from building large-scale, error-free quantum computers. Another challenge is scalability. Right now, quantum computers are relatively small in terms of the number of qubits they can use. For quantum computers to solve the most complex problems, we'll need to scale up to thousands or even millions of qubits. This presents both technical and engineering challenges that researchers are still trying to overcome. Finally, it's important to note that quantum computers won't replace classical computers anytime soon. Quantum computers are specialized machines, meaning they're only useful for specific types of problems. Classical computers will still handle most of the everyday computing tasks we rely on, like browsing the web, playing games, or running apps. So, what does the future hold for quantum computing? The progress we're seeing is both exciting and rapid. Tech giants like IBM, Google, and Microsoft are investing heavily in quantum research, and we're already seeing significant breakthroughs, such as Google's quantum supremacy experiment in 2019, where their quantum computer solved a problem in minutes that would have taken classical computers thousands of years. In the coming years, we can expect to see quantum computing grow beyond the lab and into practical use cases. Researchers predict that within the next decade, we'll see quantum computers being used commercially in industries like healthcare, finance, and energy. The development of quantum algorithms will be crucial for solving problems that classical computers can't tackle efficiently. Quantum computing isn't just a future technology, it's a technology that's evolving now, with the potential to reshape everything from how we understand the universe to how we tackle some of the world's biggest challenges. Quantum computing is a field that's advancing at a rapid pace, and while it might sound complex, its potential impact is clear. It could revolutionize industries and solve problems that are beyond the reach of classical computing. We're still in the early days, but the future is looking brighter than ever for quantum technology. What do you think will be the most exciting application of quantum computing? Let us know in the comments below. If you enjoyed this video and want to keep up with the latest advancements in technology, make sure to like, subscribe, and hit that notification bell. Thanks for watching, and we'll see you in the next one. Thanks for watching. If you're interested in learning more, check out the other videos on the channel. See you next time.